So thank you for everyone joining us for our June webinar, which will be on what can computer games teach us about traffic modeling. Our presenter today is Nick Mandler. He's an assistant vice president at TranSystems Corporation. Nick studied engineering at the University of Rhode Island and urban design abroad, graduating with degrees in civil engineering, French, and German. So after 5 years in the Division of Traffic Engineering at the Connecticut Department of Transportation, he moved to TranSystems in 2013 and has worked there ever since. Nick has a strong background in transportation modeling software and teaches a graduate course on traffic simulation modeling at the University of Hartford. So Nick, why don't you take it from there?
All right, thank you. I'll go ahead and share my screen here. There we go. So good afternoon, everyone. I'm here to talk about traffic modeling in video games. First off, I want to make the point that professional traffic modeling software is kind of a nightmare to work with. I've used an awful lot of programs, and honestly, none of them are great. The first thing I want to mention is, of course, they're all really expensive. And that sort of makes sense because they're developing these products for a relatively small audience. So they have to make their development costs back in small volumes. And that's why you can have something like Vism, which has dozens of different add-ons, and they're all extra. On top of that, their interfaces can be really difficult to work with. And learning how to use all the features in them, like this here on the right is the Vism RBC signal editor. And you can tell just by looking at it, there's an awful lot of stuff. And that takes a lot of time to learn and a lot of effort. Typically, like I said, I teach the class at the University of Hartford on modeling. It can take weeks just to go over the basics of signal design. And the interfaces themselves, I still have some issues with. The first time I opened up Vism, I didn't realize you had to right-click and drag to draw something, and it took a while to get that. It's kind of unique. I don't know any other software that requires you. Now the default is control and right-click and drag, which is even worse. And then for Synchro, the interface has taken a few steps forward over the past few versions, but still the fastest way to set up your timing is in the phasing settings, and the fastest way to set up the phasing is in the timing settings. Finally, when you run this software and you get outputs, they're okay if you're just sticking them in a table in a report or something, but it's not going to be something that someone in the public can look at and immediately understand what's going on. Especially HCS, which is just going to spit out numbers. And even when you have cases of 3D simulation like you can get in Vism and in SimTraffic, it's really not very good looking. Finally, I want to say that they're pretty slow. When we're running a simulation and it runs at real time or a couple times real time, that's nice. But then we have to do multiple runs, and you know how the huge file sizes that SimTraffic in particular works with, and Vism output files are massive as well. This kind of goes double for travel demand modeling software, just because it has to keep track of so many measures of effectiveness throughout so many runs. On top of that, if you look at microsimulation, it's modeling all the signal controllers and everything, so it's easy to see why it might be incredibly slow and take days to run a model the required number of times. So here's the interesting thing. We can think of computer games as being for amateurs, and really they are. They're just for people who have either a casual interest in traffic engineering or just want to play a game. But since it has a much larger audience and it's had a long time to chew through these issues, it has some pretty good solutions to them. First off, the price. These are the programs that I'm going to be talking about in this presentation, and all of them are 30 bucks or cheaper. You can get them on sale too sometimes for even less, but the price obviously isn't going to be prohibitive for anyone who's looking for them. The biggest strength, I think, is how quickly you can learn how to use them. and how quickly you can master them. A big part of that is because the games have built-in tutorials. They step you through bit by bit, teach you how to use the basic functions before moving on to the more arcane features. And you can see on the right here is a wiki page specifically for one of the modifications for Cities Skylines called Traffic Manager. This is entirely made by fans. It's free, and it's an excellent traffic simulation suite. This is all written, including the wiki, just by the people who made it and the people who use it. Having all that information available online in an easy to find format is super helpful. The interfaces in these games are fantastic. If you look at something like Vism or Synchro, you have so many different options, it's not immediately apparent what they do, especially once you get down into the sub-menus. But a lot of these games have very simple menus, and the structure in them inherently makes them easier to use and easier to pick up. And of course, we can't skip talking about the graphics. These games just look really, really good. If you're looking to show something to the public, showing something that looks a lot more realistic is going to basically get a lot more reaction out of people than just showing them something that looks like ants crawling on a piece of paper. If we look at Synchro's 3D viewer on the left there, and SimCity 4, which is almost 20 years old at this point, you can see how even the basic graphic style of SimCity, which is sprite-based, has a lot of spirit to it. It really captures action and vitality better than just the infinite green void that you see in Synchro. And that's with a lot less going on behind the scenes. If we look at these games and how they operate, obviously they're going to be running at a pretty high speed. If you had a game like SimCity and it was running slower than real time, people wouldn't want to play it because it would just be tedious. So the games have to do a lot of little tricks in their code to try to optimize for speed and make it so that when you have literally hundreds of thousands of cars on the road, it doesn't get too bogged down and slow down too much. There are a lot of neat tricks for doing that, and I'll talk a little bit about them later. But what you're seeing here on the right is a quick description of the lane change behavior in Traffic Manager, and basically how cars will start looking for lane changes several nodes ahead of time, similar to how they do in Vism. Speaking of that similarity, let's look at a few different ways that they're close or identical to the professional software we use. First off, for travel demand modeling, we typically use the 4-step model. I assume you're pretty familiar with it, but basically what you do is you figure out what the origins and destinations are, you pair them together, you figure out what mode trips take to get between them, and then you assign routes based on the network. Generally, when you're doing that, you're dealing with groups of drivers. So you're looking at, say, 50.62383 trips between node 1120 and node 1121, and it just gives you a gigantic matrix. In the games, we're doing essentially the same exact thing. The real difference here is that it deals with individuals. Depending on the game, these have different names. Sometimes they're called sims, sometimes they're called actors or agents. But basically, for each individual person in the game is modeling its trip generation, distribution, mode choice, and route assignment. So it's using the same basic steps. Then if we look at our professional software again, we have generalized cost and route assignment, which is a pretty basic feature. It's taking the time it takes you to get to a place and turning it into a cost using your value of time. So when you're decreasing your delay, you want to minimize that generalized cost. So that will let you take into account things like tolls, fares, and parking fees. You can also use that weighting to give drivers more realistic routes. Like oftentimes, if you have a travel demand modeling software and you're asking it to take a route between two places in the suburbs, it might be zigzagging through every single side street along the way. So what you do is you add a little bit of cost to each of those turns, and it minimizes the number of turns people have to make. In the games, it is essentially the exact same thing. There's really no difference except the things that it applies cost factors to. We'll see that a little bit more detail in just a minute. And dynamic traffic assignment, relatively cutting edge stuff. It's not commonly used on most projects, but when it is, it can be really powerful. So for our professional software, we have a pretty straightforward thing. We basically input our trip tables, the drivers choose their routes, you run through a simulation, and then based on the results of that simulation, it feeds it back to the drivers and they potentially pick a new route. Now that can happen every hour in the simulation, every 15 minutes, or just through the entire thing. But basically you just keep going and going until it converges on a solution where you can't improve the overall delay by changing routes. In the game, we're doing something that is essentially the same, with the exception that in dynamic traffic assignment, you generally have a set road network out there. Whereas in the game, there's a lot more going on. You constantly have demographic changes, you have network changes, you might be adding more modes, you could be deleting roads, you could be changing houses, you could build a university in a single click in a lot of games. So that sort of thing can have a massive impact on traffic. So in a sense, all this traffic assignment is dynamic. The drivers are always choosing their paths dynamically, and every day the driver looks at the route they took the previous day and decides whether they should stick with that or try something else. Different games have different ways of routing traffic, but generally that's how it goes. And looking at the traffic assignment and what it takes into account, this is just a screenshot from the wiki, and I want to point out that there are different levels of simulation of recalculating the routes. This is one of the little tricks that it uses to minimize the computational effort. So every time you redraw the road network, it's going to do a bunch of calculations, basically recompiling the list of routes to get from point A to point B. Then when a vehicle or an actor is trying to figure out how to get to their destination, they do a bunch of calculations and essentially figure out how they want to get there. And finally, once they're actually on the road, it's not until then that they start worrying about things like traffic lights, parking, lane changes, pretty similar to how a real person would drive. Now, if we look at some of these features in a little bit more depth, just to show you probably wouldn't expect a lot of this to occur in a game. But parking by default in most of these games is pretty straightforward. In some of them, drivers literally put their cars in their pocket when they get to their destination, then pull them back out when they want to leave. But Traffic Manager has a really detailed system that you see here in this flow chart. You don't need to read it. It's just basically, this is the same stuff that you or I do when we're driving through an urban area looking for parking near our destination, except codified and put into the game so that every driver, depending on a bunch of different factors, will choose where they want to go and how to get there, and finally where they're going to park when they get there. Public transportation timetables. One thing that I like to point out is that one of these games, Cities in Motion, and to an extent Cities in Motion 2, was originally made for developing transit timetables, and it has an incredible depth in those timetables. It allows you to put this stuff in, figure it out, and it's not the only game that does it too. Weather you might not expect to be in games, but there you go. Not just volcanoes, but snow. And as part of the expansion pack that gives you the snow that you see there on the left, it also keeps track of the quality of the road, where repaving road can result in better operations. Obviously, you're not going to want to simulate a volcano in the middle of a city, but if you ever do, the games will definitely help you do that, or meteor strikes or UFO invasions. As for special events, that is something that's incorporated in a lot of games. Some of them include tourism, but For many of these, you can have a concert or a sporting event at a stadium and see how it affects traffic, which normally requires a specialized model to do if you're doing travel demand modeling. When you get down to the nuts and bolts, using Traffic Manager, you are able to look at individual signal phasings, lane assignment. You could set up exclusive lanes, set up custom phasing. And one interesting thing that I want to point out is the way that this does detection. So obviously in the real world, you might have loop detectors, you might have video detectors or microwave. Whatever the case, it is looking at a specific detection zone and figuring out if a car is there. In this particular mod, what it's doing is looking at the queues on each approach. So the game has full knowledge of how long the queues are at any given point in time and where all the vehicles are. It doesn't need to worry about individual detectors. So because of that, you can actually help optimize for overall delay instead of just trying to guess at where the queues are using your detectors. I don't do a lot of work with railroads, but I do love playing OpenTTD. It allows you to do a ton of stuff with rail signals. You can get some really crazy setups going. And although it's pretty old at this point, it's based on a game from the mid-90s, it still has a lot of interesting aspects if you're looking for cargo transport. And you want to figure out, for example, the most efficient way to route things through a bunch of cargo stations. Parking supply and demand, this isn't just something that urban designers look at. The games have an actual way of showing you where parking is needed, where it's deficient, and potentially where you have too much of it. Multimodal freight, the screenshot on the right is from a free game called SimuTrans, which is pretty cool. Those agents that I talked about earlier don't just have to be drivers or passengers. You see down there at the bottom of the screen cap, it's keeping track of bags of mail, or it can keep track of pretty much any cargo you're looking at. So because of that, you can simulate the way it goes between modes with realistic transport times between them. Demographics are pretty handy. This is something that we're going to be talking about in just a minute, but it's difficult to directly modify these things in game. Like I can't click on a building and say, okay, I want everyone in this building to be between the ages of 40 and 60. The game is doing that all organically in the background, but you can use it to look at the different demographics by age, education, income, and using that, you can actually control who's using which mode, where they're working, that sort of thing. But of course, we are still talking about games. These aren't professional software, and they do have their drawbacks. First off, you're going to have trouble getting much quantitative information out of these. You can't go into SimCity and ask it for a level of service at an intersection. You can't get the queue length. You can get the number of cars on a particular link and potentially turning counts, but it takes a little bit of effort. You also have very little control over a lot of this stuff, and that's kind of a conceit to make it easier to use and to learn. Because you can imagine if you gave someone full control over trip generation and distribution, they would have a really tough time trying to figure that out, especially if your audience is mostly people who are, you know, like 15 to 30 years old. There is no interoperability with professional software. I can't export a city from one of these games and put it into Vism and play with it there. There are a lot of abstractions, as I mentioned before. The computational elements aren't quite as robust just because it is trying to keep these things moving at a relatively good pace. And if it, for that lane changing AI that I talked about earlier, it doesn't actually need to do that for all the cars like most software does. You can do it for a variable percentage. Say you do it for 10% of the cars on the road, have them change lanes intelligently. And that can actually make a big enough impact on the rest of the traffic stream that you don't need to model every single person keeping track of their lanes. Repeatability is a really tough one. Generally, when people play games, they want to see numbers go up. And if you are just playing a game with a completely static transportation network and the population stays the same and the jobs stay the same, it's not particularly interesting. So these games are largely built around being able to grow your own city, which makes it difficult to repeat something. If you want to go back and change something, you pretty much have to load an earlier save state. And finally, of course, it is a game. They're fun. I know if I could play them at work, I probably wouldn't get a lot done. So with mods and the cooperation of developers, we could solve a lot of these issues. But we would still have the issue of no interoperability with professional software, and honestly, getting work done might be a little bit tricky. All that given, we could still talk about how we can use this software today. First off, a lot of these transit times table simulations, we could use them for prototyping. We could change the lane use on a street and see how it affects your bus timetables. You can try rerouting your bus lines and see if it'll serve all the people you need it to. You can look at interchanges. If you want to make huge, crazy interchanges, obviously drawing this out in CAD would take you a long time. You could draw it in one of these programs in an hour or two and still get a decent idea of how it looks and how it would function. And here's a really cool one. The game on the left there is called Freeways, and it calls itself a simulation of autonomous vehicle design. It's interesting to think about how much of the designs that we do are based on driver expectancy. And if you think about a potential future where we have autonomous vehicles, things like what routes are signposted where and whether an exit's on the left or right don't really matter so much anymore. So this gives us an idea of how traffic might live in a world with left exits and left entrances wherever they're convenient, as you see on the right there. And essentially, we are designing for autonomous vehicles in these games, because even though they have individual actors choosing where to go and how to get there, it is still a computer and it's following very specific algorithms to do it. As far as public involvement goes, I mentioned earlier that these could be good for it, and it actually has been used for public involvement in the past. So Cities Skylines is made by a developer in Scandinavia, and they have used it actually to model real-world cities and have brought it to public meetings and let people play around with it. And in fact, the city where I grew up, Providence, Rhode Island, way back, I think in the early 90s, they had the mayoral candidates play the original SimCity game to see what they would do to the city, and they got judged based on it. I think one of them bulldozed a church to build a nuclear power plant and kind of got skewered in the press for that. But on the right, this is one of my projects in East Hartford, Connecticut, where we were looking at a road diet for Silver Lane. And I was able to model the buildings along the road there and show what the lane use before and after would be. So it has its uses for that. And it actually allows us to attract a completely new generation of people to public meetings that are typically dominated by pretty old folks. We want to give the younger generation a chance to look at transportation, especially if we have a big project that has something that's going to be coming online 20, 40 years down the road. The people that are coming to your meeting now, you want them to be the people that are going to be using those roads in the future. And if you're the kind of person like me and you just really like trying things out, you can go and download a bunch of different maps of various cities around Illinois. This is just a few of them. The list was actually much bigger. These are all maps that other people have made, just basically fans of transportation games. You can load one of them up. It's a blank cityscape. Some of them have the freeway network, some have the rail network, some are just trees and rivers. And you can build or rebuild the city as you like. So that's a good way to start if you are thinking of using a game for public involvement, because a lot of the hard work's already been done for you. So in conclusion, we've seen that games use a lot of the same software as the professional stuff that we use in the office. And in a lot of ways, it does it better, especially with the interface, the ease of use, ease of learning, and how quickly it runs. What I would really like to see is professional companies like PTV and Cubic taking lessons from games, maybe tweaking their interfaces or adding things like tutorials built into the software rather than just having you go online and look up videos on YouTube or something. And maybe that sort of thing can be done in a relatively short time scale. It doesn't need to be something that we wait another 10 years for, because these games, as you've seen, they progress pretty quickly. City Skylines is several years old at this point. I'm sure it has a successor in the works. And I'm excited to see how well that's going to run and how much detail it's going to put into traffic simulation. Anyway, that's it for the presentation. So now I can go on to Q&A.
All right, yeah, thanks a lot, Nick. That was really informative, and you covered a lot of information in a quick amount of time. If you have any questions, then make sure to get them in the chat or the Q&A, and we'll get them to Nick. So to start off, Nick, how is What the Game Doing different from tour-based or agent-based modeling as opposed to the 4-step process?
How is it different from that?
Yeah.
Well, let's see. Since it's looking at individual agents, basically the game is modeling the entire city at once. So depending on the size of your city, in SimCity 4, you can have literally millions of people in a single city, and it is modeling each of those people every day. So it's including a lot of demographic work in there along with the transportation stuff. If you have a TDM, it's typically going to have fixed trip tables and go through route assignment a whole bunch of times. But a game like SimCity 4, every person is evaluating every day what their route to and from work is, but they're also figuring out if they want a new job or if they want to go back to school or if they don't feel like working today and they want to go to a park or something. That's actually one of the weaknesses I find with Cities Skylines is the way that the jobs work. If someone can't find a job that they can get to within a reasonable amount of time, they'll just go to a park or something instead. And that fulfills them just as much as having a job. Like they can go to a zoo or an aquarium every single day of the year and they'll be happy. They might lose some money. That's about it.
Yeah, I'm sure a lot of us wish we could do that as an option.
Yeah.
So maybe it's not that far off from the truth. So you talked a lot about the robustness of the more casual simulations, if you want to call it that, versus the professional software. And I was curious, in the past and moving forward, do you see the games becoming more robust or the software becoming easier to use or somewhere in the middle?
I think both are going to happen by necessity, but I think games are going to grow more robust faster than the professional software is going to get easier to use. Because again, thinking about it from the perspective of the folks who program the professional software, they have a relatively small user base who spent years learning how to use their software. And it would be a big risk for them to go and immediately change up the interface to the point where they have to go through a bunch of new training for people to understand what they're doing. Meanwhile, you can't really stop the games industry. I just mentioned a half dozen or so games, but there are a heck of a lot more out there. And a lot of these free games are open source too. So you have dozens or even hundreds of people contributing to them. That's how you get games like OpenTTD, where you can download style packs that'll mimic exactly the train sets that you can get in pretty much any transit agency around the world, just because you have a lot of people with a lot of free time. So I think that the content available for the games is only going to increase as time goes on.
Yeah, it'll be exciting to see where all that goes in the next few years, and always hope for better usability for the professional softwares, but we'll see how that goes. I had a question about, you teach a course on traffic modeling. So I was curious what your experience has been using, if you have used any of the games, or if you've thought about using the games as teaching tools in your course.
That's a good question. So I've talked a lot with the students about it. Specifically, I compare the graphics in the software we use. We generally do SynchroVision HCS, and occasionally we'll get into some other stuff. But typically I say, yeah, this looks kind of bad. You can use a game and get the same thing. But it's not as useful to actually teach the students stuff, specifically because they're already at kind of a higher level. It's not like I'm going to the public and trying to show off lane use or something. Instead, it's really getting into the guts of NEMA phasing and things like that.
Okay, I think that's all the questions we have right now. Nick, I don't know if you had any final words for the audience.
If you guys want to play games and try stuff out, once you bring it into the office, just don't tell them where you got the idea. But I got laughed at quite a bit ages ago for suggesting that we use it for public involvement, even after bringing in articles showing that other places are doing that. A lot of it will just depend on the culture of your company and of the client. We have a question here.
Yeah, we have another question that just came in. So if anyone has any questions, type them out quickly, and we'll try and get them in right now. The question is the lack of repeatability actually a problem, meaning traffic does change every day?
I would say yes, it is. It's one of the shortcomings of games. I had a slide on that a little while earlier I'll go back to. But basically, since the game is constantly evolving, the game world is constantly changing, that timer in the lower left corner is just going to keep on progressing. If you want repeatability, what you have to do is save the game and load it. You could try the same thing over and over again, which is kind of similar to how the professional software does it, where it's starting from a known initial state. That's basically how it's working.
So in the majority of these games, they grow organically, or are you placing, buildings and roads to accommodate?
That depends on the game. Like Cities in Motion, the original, you couldn't touch the road network or the buildings. It was entirely here's a built city, you need to develop a transit system for it and make it optimal, try to get the best operations and try to keep it profitable. Then Cities in Motion 2 moved up to, okay, now you can build the roads, development just kind of happens on its own. If you have games like SimCity or OpenTTD, you can place buildings and industries and stuff, but they still grow on their own. So yeah, it depends on the game. Mostly it happens organically.
Okay. Yeah, thanks a lot for presenting, Nick. It looks like that's all the questions we have. Like I said, that was really informative and not your typical presentation. So thanks for joining us.
Yeah, no problem. It was fun. Thank you.
Thank you for everyone attending. We will be posting the video on our YouTube. So if you want to rewatch anything or revisit it or share it with anyone, feel free to do so. But thanks for everyone for coming in.